what this digital transformation mandate is about is a fundamental issue of corporate survival, whether you want to be on the train or whether you want to be on the tracks.
We're trying to think about new visions, new models, new methods, and how we use technology, including AI, to enable our people to create value and to deliver results for our customers and for the company.
The potential for the ways that that sort of science and automation can change the entire world is really mind-bending. The options are limitless.
You need to understand the data you have available is a core product that you have. It is value. And in order to realize that value, you need to understand how to leverage that.
This is a very large-scale effort. It's extraordinarily challenging. We're working with some of the largest companies in the world, and we're making the world a better place.
All right, hello everyone. Welcome to the C3 AI webinar series. I'm David Conkle, Federal Business Development Director at C3 AI. I joined C3 about a year and a half ago after 25 years as a military intelligence officer in the U.S. Army, and I'll be your moderator today. I'm excited to be joined by Thomas Higginbotham, Senior Director, Strategic Solutions, Sean Gooden, Senior Product Manager, and Grant Gutschall, Senior Product Manager. Today, we'll take a look at a portion of the capabilities resident within the C3 AI Defense and Intelligence Suite and a live demonstration of C3 AI Readiness and C3 AI Contested Logistics, demonstrating their applications across real-world use cases. Before we get started, I want to point out that we have a Q&A window. If you have any questions during the presentation, please feel free to drop those in there. Our team will answer them either through the chat or at the live Q&A at the end. Again, thank you all for joining us. And with that, Thomas, over to you.
Thank you everyone for joining. Thomas Higginbotham, been at C3 for 3 years, prior United States Air Force F-15 instructor. Provide a quick overview of C3 AI as a company before I hand it over to our product managers. So C3 AI, we are an enterprise AI company. We're not a contested logistics company. We're also not a readiness or predictive maintenance company, but we provide technology solutions to support all of those missions. Importantly, we work at a scale that we consider millions of models, billions of rows of data, and tens of thousands of users. That's the scope at which we work as a company. What this looks like in the Department of Defense is our application, C3 AI Readiness. The customization thereof is called Panda. That is the Air Force's system of record for all predictive maintenance and conditions-based maintenance. What this looks like, taking an enterprise approach to artificial intelligence, allows us to, over time, increase the speed to value of our efforts and also increase the reusability of all the efforts we do across different platforms. Allows us to do all this work in parallel with, again, decreased time to value. C3I is a publicly traded company. We've been around for about 15 years, over $1 billion invested into this platform. We've got over 1,000 employees and deployments across SIPR, JWICS, SAP, as well as any of our unclassed deployments. We are first a commercial company, started in 2009, and our first federal business was around 2016. But importantly, we are an enterprise platform that allows us to take any of the advancements and innovation across any of these industries and all of our customers to productize it such that the platform allows us to bring innovation at a high maturity level and a lower risk, lower cost to all of our customers. This looks like in the DoD as being able to, in 6 months with just 3 FTE, pilot any number of these use cases, whether that be operational energy optimization, whether that be contested logistics through Transcom, any personnel readiness work we do with the United States Marine Corps and thereof. Importantly, if you're going to do enterprise AI, well, one of the challenges you'll find is you need to be able to orchestrate a number of different tools, services, and just broader technologies in order to bring artificial intelligence to enterprise scale. That may include any of your data connectors to different data stores. That may be any type of relevant persistent storage technologies, be that relational databases or Hadoop storage. You'll need all of the batch and stream processing depending on your use case, any type of machine learning frameworks or services required for that use case, application development tools, UI and data visualization tools, data exploration tools, all of which need to be orchestrated in an optimized manner. The problem you get to is as any of those technologies evolve and innovation is incorporated in those, often those services break connections with other tools and services across the enterprise. That's what leads to a web of intractability that increases the cost and decreases the readiness of your AI solution. So C3 AI takes a different approach whereby the C3 AI application platform acts as an abstraction layer and an orchestration layer for all these required tools, services, and microservices. That allows us to, one, be able to future-proof the AI solution such that we manage the connection to any of the underlying technologies. That way, none of the development and data science work that's built on top of this abstraction layer is affected and it continues to operate. Secondarily, we are able to act as an orchestration layer, which allows us to then optimize all of the tools, services, and all of the processes done in order to operate at enterprise scale, allows us to provide a scalable solution both at the edge as well as in the cloud, and be able to spool up whatever resources necessary and spool them down to save costs. The output of what we do as a company is often software as a service applications, and these may be out-of-the-box C3 applications. These also may be third-party applications developed by any number of partners or customers, whereby we provide the back end. As an example, for what this looks like in the Defense and Intelligence Suite, if you have anything from predictive maintenance in our C3 AI Readiness application, our contested logistics application, both of which you'll see today. We do work in our intelligence community as well as our Decision Advantage Suite, which is our application suite for all types of TAC ISR and JADC2 type of use cases, as well as Commander Dashboard for any type of personnel readiness and whatnot use cases. As we discussed today, we'll hear from our two product managers on contested logistics and C3 AI Readiness, starting with the former.
Hello, everyone. My name is Grant Gutchow. As Thomas mentioned, I'm a senior product manager here at C3 AI. Before joining C3 AI, I was a Marine Corps officer focused on cyberspace operations and information operations. But our work with contested logistics wasn't created in a vacuum. Our contested logistics application stems from years of commercial supply chain use cases that we've engineered as SaaS applications, but also recently our work with Defense Logistics Agency and United States Transportation Command and various services that have similar problems that we've been able to abstract away and build this core contested logistics application that we're going to talk about today. So I'll spend 5 or 10 minutes giving you some slides to introduce you to the application, and then I'll actually show you a demonstration where we can follow a synthetic workflow through the application and show you how it could be used to optimize your logistics missions today. So many of you are probably familiar with the idea of contested logistics, but really what makes it more complex in a military environment than it would be in a commercial supply chain environment is this idea of adversarial interference, as well as geopolitical shifts and, of course, inclement weather that could affect facilities, it could affect missions, it could affect the assets that are transporting the materials between facilities. So there's this holistic problem that needs to be aware of all of the different possible shortages and delays and effects that could impact your AO and your ability to get the right things to the right people at the right time. And more specifically, we find today that logistics teams, especially military logistics teams, lack the appropriate tooling to effectively monitor, plan, and adapt to these constant changes. So that the concept of monitoring, planning, and adapting is going to be really central to what we're talking about today. Being able to think about a campaign planning tool, accelerating that, automating it, trying to get ahead of things and proactively offer opportunities within this holistic common operating picture view. So an incomplete picture of all logistics missions can really be detrimental to efficient and effective planning and just the communication between military units that is often gapped and is often reactive when it comes to contingency planning. There can often be months-long planning cycles that then ultimately are worthless once things hit the battlefield and start changing. So our solution to these problems that we face in the logistics spectrum is our C3 AI contested logistics application, which is really this enterprise AI solution that is a starting point allowing you as a military logistics operation to unify disparate data sources that we'll talk a lot more about, but also monitor all of the missions and facilities and assets in near real time across a variety of different spectrums of warfighting. Planning scenario-based campaigns we find is a critically important functionality, being able to develop workflows and sandbox situations, making sure that all of the contingency planning is right in front of you and you're able to quickly bring plans off the shelf and into effect as quickly as possible. And finally, adapting to real-time contingencies, being able to adjust supporting capabilities, understand why the artificial intelligence is telling you something, and very importantly, not trusting a black box system to operate things in the warfighting environment. So I'll spend a few moments talking more about these individual bullet points that I talked about. First being the data unification aspect, and many of our C3 AI applications are very good at managing mass amounts of data sources through our C3 AI platform that Thomas talked about a little bit previously. So the data sources that we've already fused into this application and things that we continue to manage are the Transcom port and mission data, GCSS for Marine Corps and Army, State Department advisories, CIA World Factbook, a combination of open source third-party intelligence, as well as internal NIPR, SIPR, JWICS data that is all available through Advana and through the C3AI platform deployed on top of that. And then finally, once we've aggregated the data and we've normalized it and cleaned it and made it ready for use, we visualize it in a very intuitive set of interfaces that you see on the right-hand side. So making sure that everyone is able to onboard to this application and gain mission effects as a result of all of this work we've done upstream within the data. Our goal is that an 18-year-old analyst fresh in uniform is able to leverage these logistics tools and provide immediate effects to the commander and to the mission. So the data unification is very important when it comes to a contested logistics application and thinking about all of the domains of warfighting contributing towards a holistic logistics operating picture. So on the topic of a logistics operating picture, this control tower concept is it's the JADC2 of the logistics spectrum. It's being able to track missions and facilities and assets and units and suppliers, making sure that not only can you see where everything is at any given time, but also the lead times, the predictive analysis of delays and shortages so that you can make decisions before it becomes a real problem. So being able to see everything is critically important, but then we start to alert and predict and offer conflict resolutions within the system. And you'll see some of that in the demo here in a few minutes. But this control tower concept is really your geospatial common operating picture where everything can be visualized, managed, and even thrown up on an operations center wall if you want to just leave it there and track things that way. So it's great for both desktop use as well as your global operations center, a wall of screens view. So taking it a step further into, away from just visualization and more about actual campaign planning and sandboxing of warfighting environments. So we call these workflows, and resiliency planning that you see on the screen here right now is just one category of workflow. So the concept of resiliency planning is that you're able to go into this application and see today's world, today's present state of your missions and facilities and assets that I talked about earlier. But you're also able to say, what if I take out one of my logistics nodes? What if I degrade one of my airport capacities by a factor of 50%, or a seaport that I've removed one of my port docking abilities. Or maybe you're actually doing the reverse, and what the Marine Corps calls expeditionary advanced base of operations. Maybe you're creating a node in the environment, and you want to see how that creation or degradation or denial of a node in the logistics environment has secondary and tertiary effects on your AO. So on your area of operations, what happens if you do something, and how does that have secondary and tertiary effects on your environment? So that's the concept of resiliency planning, being able to ask, what if such and such happens? What will happen as far as my survivability and throughput of all of my logistics missions? So just one category of workflows, but we have dozens of these across our commercial and military logistics applications, everything from predicting shortages to recommending alternative plans. And we'll talk about a few of those in the demonstration coming up. And all of these capabilities, I mentioned it briefly earlier, but the explainability and the auditability and the transparency of artificial intelligence and machine learning algorithms is all available within these applications through what we call supporting capabilities. So being able to track and adapt algorithms, making sure all of your features are explainable, making sure that you have very simple visualizations about the weighting of features so that you don't have to be a PhD or a master's in computer science to understand what this artificial intelligence algorithm is giving you. The explainability, critically important, that we found across the federal customers that we have, but also being able to manage the reporting and alerting and tweak these algorithms if they're not performing to your standards. If they are alerting on things that you know aren't really a problem, you're able to manage those alerting and reporting within the applications as well. So these are just supporting capabilities that really offer you a tailored application and offer you a tailored experience for your specific unit. This is not a one-size-fit-all application. This is simply a starting place that allows you and your mission to quickly get to the meat of the problem and offer solutions through our application suite. So with that, I'd love to show you a demonstration of the application. As I mentioned before, it's synthetic data, so I'm not showing any classified or customer data here, but it's a pretty realistic example of where we're taking this application and how it can be used to solve problems within the AO. In this case, the demo will be through the Indo-Pacific region. So I'll click through this video here and ensure that you're seeing an application that is realistic. And what I see is I've entered into the contested logistics application, and specifically the control tower view. So this geospatial common operating picture that I can see all of my world of logistics, missions and assets and facilities, and then the alerts on top of those. So here I see there's actually one mission that's at risk in my Indo-Pacific region. And I can click into that mission and see, why is it at risk? Tell me more about that detail. This would be an example of a desktop use of the application. And immediately by clicking the mission, I see where it's coming from, where it's going to, what the timeline for that mission is, and I can start to see the delays, right? The multi-hop effects of the mission. And on the right-hand panel, I see details such as, why am I getting this alert in the first place? It's a combination of intelligence reporting and anomalous AIS tracks and maybe even weather data or anything else you're plugging into the system from those data sources I saw earlier, affecting what a mission delay might be. And then I can see the mission details here, as well as delay predictions, so more explainability from the artificial intelligence predictions, and then any asset details I have as well. So trying to solve problems within the common operating picture is very important. But instead of trying to click through here and go to detail pages from the control tower, I can also click into our workflows. So the workflows I mentioned are a set of disparate capabilities that are all context aware. So they're all aware of each other, from mission planning applications to mission execution applications, to even domain awareness applications. So thinking about all the different ways you could cut the JADC2 data sources, multimodal entity fusion, data veracity, collections management, et cetera. But I mentioned that these are context aware. So what I mean by that is, with logistics, there are often secondary and tertiary effects. When an asset's delayed, a facility might be shorted. And in this case, the logistics supportability analysis application, something we built for the Defense Logistics Agency, is displayed here. And I see that there's actually a fuel readiness threshold that is gapped because that asset was delayed in my control tower. So when the asset carrying fuel is delayed, there's going to be problems at its destination facility that was expecting that fuel and that needed that fuel to continue operations. In this case, I've clicked into the Port of Guam detail page within the logistics supportability analysis application, one of the workflows inside contested logistics. And I see all the details around the Port of Guam. Where is it? What are the AIS tracks available, kind of real-time information that I'm getting. But also within the logistics tab, all of the supportability across all of classes of supply at 30, 60, and 90-day windows. So in this case, I know that the asset carrying fuel was delayed, and now I'm starting to see a problem at the 60 and 90-day window around fuel, around class 3 supplies. And I can view the details there on the right-hand side where I'm actually seeing I'm going to fall outside of thresholds. I don't have enough nominations, enough orders that are coming in the near term to solve this problem. So I'm now convinced that I, as an analyst working on this application, need to do something about it. So what I can do is actually navigate over to the risk mitigation tab, where for every alert we're generating, we're actually offering you solutions as well. So we're trying to create courses of action recommendations, COA recommendations, for any alert that we're surfacing. And these optimizations are for a variety of reasons, right? There's a geospatial view where I can see that initial alert, but the 3 COA recommendations you see above can be optimized for speed, right? I just want my equipment as fast as possible. I want to optimize for resiliency, right? I don't want to make too big of waves within my AO to try to solve this problem. Or maybe I'm optimizing for cost, right? Especially important for commercial ends, but occasionally it can be important to optimize for that in the military as well. So from any of these COAs, and obviously these are just example COAs, we can create optimization models for a variety of use cases, but I can view that solution, see it on a map, see what the alternatives are, read about the metadata there about what I'd like to do. And then ultimately it's about recommending that and actioning that recommendation up your chain of command so that they can see exactly, what will happen and what is the proposed solution back in the control tower. So making sure that everyone who's using this application is aware that someone's made a recommendation. There is a proposed track that would solve that initial mission problem. But in just a few minutes, I've stepped through kind of multiple logistics problems and been able to solve them within the application based on machine learning recommendations. So happy to take questions about that following the C3 AI Readiness demonstration. But this is just a quick example of how a contested logistics application can make an immediate difference within the warfighting domains and accelerating this all-domain logistics viewpoint. So with that, I'll hand it over to Sean Gooden, another product manager.
Hello, Grant. Thanks for the introduction. My name is Sean Gooden. Prior to joining C3 AI, I was a former Army engineer officer and transitioned just post-command. Today, I'm going to talk with you about C3 AI Readiness, which is our AI and machine learning predictive maintenance solution for fleets of vehicle assets in any domain, airspace, land, or sea. Today, I'm going to share with you how the Readiness application maximizes mission capability and asset availability. The 2 leading causes of asset unavailability are unplanned downtime due to unscheduled maintenance events, as well as additional unplanned downtime due to the lack of necessary parts in order to complete a maintenance requirement. And so what the application does is it enables maintainers and sustainers across the defense enterprise to effectively mitigate these 2 leading causes so that they can transition from a more reactive base or reactive type of maintenance to one that's more proactive, where they're scheduling maintenance based off of the early detection of potential failures and ordering parts or ensuring that they're on hand at the time of maintenance. As we look across the OD at how maintenance is typically done or done today at many units, if not most, there are 3 pain points that I'd like to briefly just cover. The first example, and it's one that I can relate to from my time as a company commander, but commanders and unit leaders are dependent upon bottoms-up reporting to understand updates in vehicle status or mission capability reports. And then they also have limited visibility in terms of what are the underlying causes of blockers to or maintenance resolution pathways. So this can be very challenging because it makes it very difficult to make informed maintenance-related decisions or assist in prioritizing maintenance activities. The second example is in instances where we see that a unit might have a predictive maintenance solution. What we find is that the vendor takes a rules-based approach where they're overly reliant upon threshold type alerting. The issue with this is that this approach can be very noisy with false positives. And so if you think about a field maintainer who removes an asset from service so they can then go in and investigate that alert. And time after time, they're finding that these are false positive alerts. As you can imagine, they begin to lose confidence in that tooling or solution that's been provided to them. And then the third pain point that I'd like to point out is that the available information systems fail to facilitate the linkage between the prioritization of maintenance activities and the prioritization of actual operational requirements. And what happens in turn is a lot of extensive coordination to ensure that you have assets that are available and ready for actual operations. But the C3 Readiness application is designed to address these head on. For example, by first providing a global view of mission capability and fleet health down to the vehicle level, by also providing those predictive alerts so that our maintenance teams can make that transition from reactive to proactive maintenance, and also driving efficiencies in maintenance operations through unique workflows such as operation schedule optimization and providing in-application part visibility. Diving a little deeper into the global fleet health, a couple of things I'd like to point out are that this unified view, what it does is we are able to move beyond just the binary, is a vehicle up or is it down? We can begin to truly understand the criticality or around the fleet health of an individual asset. And this helps to understand the problem and ensure that we're taking the right corrective actions. Across the top, you can see here that we have metric tiles that have key performance indicators. These are easily customizable for the different services or customers. And then beyond just a dashboard that's rich with information, we're able to provide, again, those workflows that allows a user to dive deep and understand the underlying causes of why a mission capability rate hasn't recovered for an asset or why specific alerts have been triggered. The core capability of the Readiness application are those predictive AI machine learning alerts. And these are generated through two approaches in the application. The first is survival analysis, as well as our sensor-based algorithms approach. And underlying this are transparent evidence packages, which I'll dive into a little bit more. But I just want to cover what we're doing with these two approaches. For survival analysis, we are taking historical maintenance records and using natural language processing to identify repair and replace events for a specific component. And then on the back end, we are executing Weibull analyses so that we can then render a Weibull plot and enable the designated individual to establish a remaining useful life threshold relative to a desired % of unreliability. And in the case of sensor-based algorithms, we are taking onboard telemetry data from the assets and pairing that with operational data to then model what the healthy behavior of a system looks like. And then when the system or the system deviates from that healthy behavior, an alert is triggered indicating that that there is that anomalous behavior, and the user or team should investigate further. And the last thing I'd just like to share is with the C3 Readiness application and like Grant just shared in contested logistics, we don't believe in black boxes. We want to make recommendations to the user and truly help them understand and contextualize why that alert was triggered. And so we have visualizations such as our time series of risk score over time, over successive operations, so that the user can understand how that system was behaving previously and how, if that deviation has significantly degraded, We offer insight into the top contributing features that contributed to that alert. And then we also show you that modeled healthy behavior relative to the actual, so that the user can see what the residual is and the extent of that deviation. And to kind of close this up, we're not only providing those AI machine learning alerts, but then when it comes to maintenance operations, we're providing those workflows that are designed to, again, improve asset availability. And so, if you think about field maintainers, we're pairing up the technicians with the correct proficiencies for specific work orders. We're optimizing our maintenance schedules, and then we're also providing, since we have that demand signal on part failures and the feedback that follows those alerts, we can forecast out and ensure that we have the necessary parts on hand to perform maintenance at the time of that scheduled event. And to kind of close it up here, we pointed this out at the beginning of the presentation, but this is the application or the extension of it for the Air Force that the Air Force has designated as a system of record for predictive maintenance. I'll transition now into a demonstration of the C3 Readiness application. Okay, for the purposes of this demonstration, let's assume that I'm a maintenance analyst in a systems program office in this particular case, for a nominal X-1B aircraft platform. My responsibilities include monitoring and reporting on reliability trends across the fleet, helping to prioritize maintenance actions across the fleet, as well as providing guidance to field maintainers on opportunities to improve asset availability. In my day-to-day, what I'm prioritizing is identifying where my highest risk systems are, either at the vehicle level or down to the subsystem level, and then working across the enterprise, and whether it be in the program office or with field maintainers, to make sure that we are addressing maintenance issues. Very quickly, I'll orient you to the dashboard. At the top here, you can see metric tiles that help me understand what my mission capability rates look like, what my fleet readiness looks like across the fleet. As I continue to move down, I have details on the platform at a high level. I can also see month over month mission capability rates by mission capability category. I have my highest risk aircraft as well as my highest risk systems and latest open AI alerts. Down here, I also have my high priority cases. These might be cases that I initiated myself or that I'm currently assigned, and so this gives me a way to quickly access those. And here in this geospatial view, if my fleet is distributed across the globe, I may be concerned about impacts, operational impacts or weather impacts on readiness and its impact to aircraft within my fleet. Sorry. Moving back to the top here, I start my day and I realize, or I review the fact that my fleet readiness is at 63%. And I also see that my operational time at risk has been increasing. Over the last 30 days, the fleet readiness has been fairly consistent, but I see that month over month, at least for the last 2 months, we've had a significant decrease in our mission capability rate. This is tied to increase in operational tempo. So I'm aware of that, but I want to make sure that we're addressing my highest risk aircraft and systems, which I can see here. My highest risk aircraft is TEL 84, indicated here with a risk score of 84. As I move over to my highest risk systems, I see that TEL 84 actually has a number of alerts on different systems. In particular, this system here, Alpha 856, with a risk score of 87, has had a uptick in that risk score of 20 since the last flight. And so I definitely want to take a look at this most recent alert associated with the system. As I shared, we do not take a black box approach. We provided a trigger or an alert. We want the user to understand why that alert was triggered. And so as I move from top to bottom, with the risk analyzer, what I can see here is my risk score over time or over successive operations. I'm going to just zoom out here a little bit more so we can see a wider length of the time series. I have indicators here such as a previous maintenance event with details. This indicates that this issue was looked at previously, but no issues were found and it was installed. And then here on this operation in late September, I see that an alert was triggered. And then as I look to understand the behavior of the system over time, I see that it's gradually increased until this alert was triggered. Moving down to the bottom of the page, I want to understand what is actually contributing to this alert being triggered. I see these feature contributions here. You see in-air temp, fan RPM, and vane RPM with their percent contribution. I want to dive a little bit deeper and just validate that these are how these sensor feeds look and better understand how they contributed to this alert being triggered, so I can very easily add them here. So we have vane RPM, in-air temp, and fan RPM. And what we see here is that relative to the alert being triggered, across these data feeds, we see that there was an uptick in the readings here. This seems to be fairly consistent with an issue that we've seen in the fleet with the inlet vane guide. The inlet vane guide controls the amount of airflow into the engine, and if it's not operating appropriately, it could cause the engine to stall. So what I want to do here is we definitely want to take a look at this issue. I can open a case here. To accelerate this a bit, I won't fill out all the details, but you can see here we have case ID, case name, description. I can add a due date, and I can also assign it to an individual for review or to take a look at. So I do that, and what we get here is our case details page. As you can see here, I have all activities related to this particular case. I can add comments, and I can add teammates within the comments to get them or to begin coordinating, collaborating with them on this particular case. I can also append documentation such as technical manuals and engineering bulletins. This is really great because what we're able to do is essentially create a historical record of this particular issue for reference later to share with new maintainers that are coming online so that they can get trained up and up to speed. One last thing I'd like to point out here is that on the left side, again, with the readiness application, we are focused on maximizing asset availability. And so if we're taking a vehicle out of service to investigate and alert on it, there might be other alerts that we could attach to this case so the maintainer can look at those all at once and reduce any additional unplanned downtime. I've collaborated internally, and we believe that this is a case that should be forwarded to a maintainer in the field for further investigation. I can simply do that here. This is another modal that goes to a specific field maintainer. And so we're collaborating with the field maintainer. They're validating whether or not it's a false positive or a true positive, and we can quickly resolve this issue and close out this case. So this concludes this part of the demonstration. Let me close out here. Okay, to bring it all together, we've had an opportunity today to introduce both the C3 Contested Logistics product as well as C3 Readiness. And now that you're more familiar, we want to share how these two products together can amplify the benefits that the individual products on their own would offer to the customers and to the enterprise. I have a couple of scenarios here just to orient you to the screen. On the top, we have the maintenance team using C3 Readiness, and on the bottom, we have logistics teams utilizing C3 Contested Logistics. But in this first scenario, there's an alert on an asset, and we need a critical part. And so either in direct coordination or even just in parallel, because both applications are optimizing within their specific lanes. in this particular case, contested logistics may be being used by the logistics team to identify delays in getting specific cargo containers to a final destination, and may work to divert cargo or move it to another shipping container. And what ultimately happens is the maintenance teams on the ground are able to get that critical part much faster. Again, accelerating that resolution pathways, resulting in a reduction or mitigation of additional unplanned downtime. And in the second scenario, it starts with the logistics team, again, operating independently or in coordination with maintenance professionals. But there's a logistics plan or campaign that's planned, and you need some sort of shipping vessel or aircraft to move cargo. And so the maintenance team, using C3 or the C3 Readiness application, is optimizing maintenance and maintenance schedules, freeing up additional capacity on assets that come online, better supporting that campaign plan that was done in contested logistics. So hopefully you can see here the benefits of not only the individual products, but if you had both products operating together. This concludes this portion of the demonstration. I'll transfer it back to Dave. Thank you.
All right, thanks, Sean. Okay, so we'll go to question and answer. We've received a few questions already, and so we will jump in. The first question will go to you, Grant, and contested logistics. Does the logistics forecast account for factors such as political climate, natural disasters, weather, and workforce level of effort?
Great question, and something that I can say for the most part, absolutely. That data fusion slide that I showed earlier in my presentation spoke to a few of the different data sources that we can incorporate to account for things like weather and to account for things like global climate and political climate and kind of the news and sentiment that's happening around these ports and airports that may affect logistics operations. So we definitely consider as many of the domain factors as we can across all domains of warfighting, as well as publicly available and commercial data sets. We're able to pull those in and help fuse kind of a feature-rich algorithm to predict delays and predict shortages. Obviously, we never, incorporate, demographic data or certain data that could be biased or unfair to subpopulations, but all of our features are explained in the application to make sure that we're painting the best picture and the most likely outcome to the available data.
Okay, thanks, Sean. You'll get question number 2. Logistics views of the tools. What is the availability to have custom view for a single AOC? And in this case, I assume that AOC is Air Operations Center. So what's the availability to have a custom view for a single Air Operations Center versus an enterprise view for a group like Transcom? And does this exist already?
Got you. So for contested logistics, we're able to work with the customer to make sure that we are providing them with a view that works best for them. What we have at contested logistics is essentially a framework or the skeleton and bones of workflows and additional or workflows that support decision making. And so we could definitely adapt those to specific customers.
All right, Sean, we'll stick with you for this next question. And who is the target audience of the SBA products? Leadership, scheduling, or technician?
Yeah, so if we're thinking about the more technical aspects of sensor-based algorithms, that's probably going to be a reliability expert, same as like our commercial implementations in the oil and gas industry. The primary persona there are reliability engineers. And so they're going to be familiar with the systems and be able to go through that flow I showed you of on that alert details page to understand what's going on with that system that they're very familiar with, and be able to make a recommendation to those field maintainers on whether or not this is an alert that we should actually go forward and investigate.
All right, and Grant, can you clarify if the information is presented in real time or near real time, and kind of what the difference is in relation to the application?
Yeah, another great question, and one that I think most of our C3 applications, we trend towards the term of near real time. And the reason we do that is because we are getting the data essentially at the speed of light from wherever the data is produced, right? So I know some subsystems like GCSS Army and GCS Marine Corps, they may only be updated once a week or once a month, depending on the unit and their mission cycle. And maybe they just don't have great bandwidth if they're, producing data off of a ship. So if the data is produced at a once a week period, we receive the data at a once a week period, and then we visualize it, as quickly as we can. So some data sources like your AIS tracks that are broadcasting off of ships themselves, those are updated every few seconds and available in near real time, versus other data sources like GCSS, supply logs, some maintenance logs, those are updated less frequently. So when you think about the holistic application, we use the terminology near real time, but it really just depends on the data source and what kind of thing you're trying to visualize.
All right, Grant, we're going to stick with you. Camera's off a little fast. Shortage predictions. Do you have a way to show an example of that here, or what?
I can't show a customer example in this format, but happy to follow up offline with maybe a more specific type of question to kind of talk about shortage predictions. We have different algorithms, and as Thomas mentioned, we often run hundreds of algorithms for a single customer. We have millions of algorithms in production today. But when you think about the things that might cause a shortage, we talked about weather, we talked about adversary influence, we talked about asset problems. If a C-130 is broken, it can't deliver things, and that will cause a shortage. So it's really about kind of fusing all the data together and then being able to predict kind of the average timelines for receiving items. And then if something starts happening and problems start arising, then that average timeline will start ticking up. So it's really about taking in all of the available information, looking at averages across every supply shipment in the AO, and then trying to determine if things are going to be off the average as a result of that, for better or worse.
Okay, next over to back to Sean for the next two questions. Sean, behavior that appears anomalous can appear for many reasons. Pilot influence, mission, or environment can directly correlate with spikes in performance. Do your systems account for confounding factors prior to issuing alerts?
If we have data that would signal to us those particular inputs, what we're doing is we're taking, again, that telemetry data and we're pairing it with operational data to model what right looks like, what a healthy system looks like. And then we would get if there is anomalous behavior, we would see those deviations. What ultimately will happen is a maintainer may go and investigate that. That maintainer is going to be more familiar with what's happening in terms of operations with that aircraft. But yeah, that is what we're doing. We are literally taking raw sensor data and using our machine learning pipelines to make a determination on whether or not there's that anomalous behavior and make a recommendation to go and do the investigation. And those might be concerns or input that would go into that case for consideration.
All right, Sean, and the next question is yours as well. Assume you have NIPR and SIPR instances. Are you considering DRRS-S, so Defense Readiness Reporting System strategic data to understand current and projected unit capabilities and commanders' comments to fully understand the logistics and maintenance concerns?
For sure, we would pull that in, right? So if we want to have, we're presenting mission capability data, and so that would populate within the application. And if that data source is available, we would make it available within the application. there's no limitation there.
Okay, sorry, I was on mute. Headspace operator timing. Grant, this is for you. Multiple military units are required for logistics missions. How do you ensure collaboration?
Yeah, a lot of great questions today. I think the way we ensure collaboration is within the application, right? Providing all of the insights that users need to make decisions. And those insights are customized based on the users themselves, right? So if it's Transcom working on the application, we want to offer them insights that they can action within their authorities. But in terms of fostering collaboration outside of the application, that's something where we really are a strong proponent for getting all of the stakeholders in the room. And we have an office in Tysons, Virginia, so right up the street from the Pentagon, and making sure that we're having these cross-functional meetings across all of our customers and sort of a thought leadership council that everyone can contribute, everyone can make decisions together for the benefit of the warfighting environment, right? It's all part of the process is getting the right people in the room to give their input and build an application around what will make an actual difference. So the collaboration within an application is very important, but just as important is the collaboration outside of the application as well.
All right, and so far this will be our last question, unless something pops in by the end of this answer. This is for Sean. Sean, we've talked a little bit in here about C3 AI Readiness being a system of record for the Air Force. Does the application only work with Air Force systems, or do they work with other platforms other than aircraft?
The Readiness application is intended to work for any type of vehicular asset. So Navy applications, ground combat vehicle applications within the Marine Corps and the Army. Even for the Readiness application, there was a lot that we took, or a lot of learnings that we took from the commercial side with our reliability application. As we shared earlier, we're monitoring millions of pieces of equipment. We have millions of models that have been deployed. And at the base of it, right, we're going to follow the same model deployment framework. In order to develop these specific models. Some systems are, you'll have propulsion systems on different types of vehicle assets, so ships and on aircraft, where they're very similar. But what's important to note here is that C3AI is going to work with SMEs that know these specific systems, and we're going to identify which systems are the appropriate ones that we should be modeling and deploying into the application.
Okay, it looks like those are all the questions we have for you guys. So I just want to say thanks, Thomas, Sean, and Grant. And we're ending on our allotted time anyway. So thank you guys for your presentations. As a quick reminder for the audience, this webinar is going to be available on demand, and you're going to receive an email with the link later today. And if you enjoyed the content, please follow C3 AI on our socials, LinkedIn, Twitter, and YouTube. And so thanks again for joining us, and we hope you guys have a great rest of your day. Thank you.